So good morning students, welcome back. Today we'll discuss one of the most important topic, meter base. That is practical also. So now first we'll discuss theory and later on we'll discuss practical also. So look students, very first thing, what is meter base? Meter base is a device that is used to find the resistance of unknown wire. It means with the help of meter base we can find resistance of any wire. Suppose this is copper wire, and if you want to find the resistance of this copper wire, you can find with the help of meter base. Okay, look students, that is the construction of a meter base. That is a circuit diagram of a meter base. First of all, I am going to explain you the circuit diagram. Look students, construction of meter base. It consists of a 100 centimeter long wire AC. Look, this is the point A and this is the point C. This is 100 centimeter long wire AC, and this wire is made by Eureka, either manganese or constant. These are alloys. Why we use this wire? It is made by Eureka, either constant or manganese, because these alloys having low temperature coefficient. Okay, it gives the proper deflection. Now since AC wire is 100 centimeter long, along with parallel we are having 100 centimeter meter scale. This is the meter scale, and this meter scale used to finding for for finding the balancing length. Okay, now students, look, terminal A is connected with cell, okay, with switch, and another end of the switch is connected with point C of the wire. Okay, and it consists of a bronze strips. Look at students, this is the bronze strips. This is made by bronze, and this bronze strips having two gap in between, right and left. At right gap there is connected a wire S. S is said to be unknown resistance. Actually we have to find resistance of this wire. This is unknown wire. And left gap we are having a resistance box. Okay, the mid terminals of bronze strips is connected with a galvanometer, and other end of the galvanometer is a free wire that is said to be jockey wire. What is the use of this jockey wire? With the help of this jockey wire we can find the balancing length, okay, by sliding on wire AC. That's why it is also said to be slide wire bridge. It is also said to be a slide wire bridge. So this is the basic construction of a meter base. This is unknown resistance, okay, and we can find the value of unknown resistance using this meter base. Its principle. The meter bridge, either slide wire bridge, is based on the principle of Wheatstone bridge. P upon Q equals to R upon S. That is the principle of Wheatstone bridge that we did before, and on that principle meter bridge is based. Okay. Look students, the working part. In working, what we do? How can find the value of unknown resistance? Look students, we have to perform an experiment. What will do students? First of all, when switch K is on, current I will flow in wire AC. Current I will flow in wire AC. Now the second thing, after switch on the key, okay, we will remove out a suitable resistance from resistance box RB. Suppose we are taking as 2 ohm. Okay, we'll remove out 2 ohm key from this resistance box after switch on key K. Okay, we'll remove out 2 ohm resistance. Understood? Now students, the next third step, we will hold this jockey wire, okay, and slide over the wire AC. This is the wire AC. When we touch the jockey wire at any point, sometime we will get deflection at right side in galvanometer, sometime left side, but we have to find at that point at which the galvanometer shows zero deflection. Suppose when we touch the jockey wire at this point J, suppose this is J point, at that time galvanometer shows zero deflection. When the galvanometer shows zero deflection, in that condition, okay, from point A to point J, this AJ distance is L. That is called balancing length. That is called balancing length. Okay, so remaining J to C will be what? 100 minus L, because AC wire having total length 100 centimeter. So if A to J is L, so remaining J to C will be what? 100 minus L. Okay, and this is said to be when galvanometer shows zero deflection. This is said to be balancing state of the bridge. In that condition, the ratio of four resistance PQRS will be P upon Q equals to R upon S, because meter bridge is based on the principle of Wheatstone bridge. Okay, R, we know how much we remove out 2 ohm resistance. So R is given. Okay, we found. S is unknown resistance that we have to find. So we have to find only two resistance, P and Q. We know the formula. R equals to rho L upon A. Resistance is directly proportional to the length of the wire and inversely proportional to the area of cross section. And rho is called resistivity and it is said to be specific resistance. We did before. So now using this formula for P, look students, P is showing the resistance between A to J. So what should be P? P should be what? Rho L by A on account of this formula, and balancing length L. So for J to C, the balancing length is 100 minus L. So I draw 100 minus L upon A. Area of cross section of wire remains constant. A to A cancel out, rho to rho cancel out. This is L, 100 minus L. Look students, we have to find the value of unknown resistance S, transfer S, 100 minus L upon L into R. L we can measure using this meter scale. This may be 30 centimeter, 40 centimeter, 80 centimeter, maybe 90 centimeter, 95 centimeter. And R, we remove out 2 ohm resistance. After putting that, we can get the value of unknown resistance. Okay, in this way we can find the value of this unknown resistance. Now we can repeat this experiment. Same experiment we have to repeat, but instead 2 ohm, we will remove out 4 ohm key. Okay, then 6 ohm, 8 ohm and 10 ohm, and we'll repeat the same experiment and we'll get the different values of unknown resistance. In this way we can perform an experiment meter bridge.